Welcome to this video on conducting a chi-square test of independence. Let's begin. After watching this video, you will be able to determine whether all requirements of a chi-square test of independence have been met, calculate expected frequencies by hand, calculate the chi-square test statistic by hand, and conduct a chi-square test of independence. You will also be able to describe the chi-square distribution and explain how it differs from other distributions. Requirements for using the chi-square test of independence. You must be comparing two categorical or qualitative variables. The sampling method must be simple random sampling. The samples must be independent, and the sample size must be large enough that all expected frequencies are greater than 1, and at least 80% of those expected frequencies are greater than 5. Example 1. Smoking versus gender. A survey was distributed at Anytown Community College. The students were asked if they smoked cigarettes and their gender was recorded. Is this an appropriate application of the chi-square test of independence? First of all, are we comparing two categorical variables? Well, one variable is, do you smoke cigarettes? So the answers to that question would be yes or no. That's definitely categorical because it's a label. Likewise, the gender, in this case we're going to split them into male and female, is also considered categorical or qualitative. Was the sampling method simple random sampling? We will assume that random sampling was done. Were the samples independent? Again, we will assume that this was the case. So now we have this last requirement, which is that the sample size is large enough that all expected frequencies are greater than 1, and at least 80% of them are greater than 5. So unfortunately, in order to check this requirement, we're going to have to calculate the expected frequencies for this data set. So here is our data set. So let's look at this for a second and interpret it. So again, we're splitting people into female and male. So 327 females said that they do not smoke, and 95 of the females said that they do. 144 of the males surveyed said that they don't smoke, and 84 of the males said that they do smoke. And then the numbers out here are just our subtotals, and we're going to need them when we calculate our expected frequencies. But the raw data summary is just these four numbers in here. So in order to calculate your expected value, we have to multiply the row total by the column total and divide that by the table total. So hopefully you're starting to see why we needed these subtotals. So let's start. We have to calculate the expected frequencies for 1, 2, 3, 4 different boxes. So we're going to have 4 different expected frequencies, and in order to meet this requirement, they all have to be greater than 1, and actually they all have to be greater than 5. So let's begin. Let's start by calculating the expected frequency for the females who said they don't smoke. So our row total for this box is 422. The column total is 471. And the table total, meaning the total number of people who were surveyed, was 650. So we're going to have 422 times 471 divided by 650, and that gives us about 306. So clearly 306 is greater than 5, so this requirement has been met. We're going to continue this process with the other 3 boxes. So let's look at the females who said yes. So the row total is 422, the column total is 179, and of course the table total is still 650. Doing the math, we have an expected value of 116, which again is still greater than 5. Continuing on, the expected number of males who said no, we have a row total of 228, a column total of 471, and a table total of 650. When we do the math, we get an expected value of about 165, which is clearly greater than 5. Lastly, let's calculate the expected value for males who said yes, they smoke cigarettes. So the row total is 228, the column total is 179, and the table total is 650. When we do the math, we get an expected value of about 63. Again, this is still greater than 5. So notice that the expected values I have placed in parentheses, and notice that all 4 of these values are greater than 5. Therefore, this requirement has been met. The chi-square test of independence is a hypothesis test. Let's review the steps of a hypothesis test. Step 1, check that all requirements are met. Step 2, write your null and alternative hypotheses. Step 3, conduct the hypothesis test using the critical value method or the p-value method. Step 4, make a decision to reject or retain or fail to reject the null. And step 5, write a statement summarizing your findings. The chi-square test of independence, a hypothesis test. The chi-square test of independence is a hypothesis test. Like other hypothesis tests, when we perform a chi-square test of independence, we identify the null and alternative hypotheses. Unlike other tests, however, the statements are always the same. The null hypothesis for a chi-square test of independence is always that the two categorical variables are independent, while the alternative hypothesis is always that the two categorical variables are dependent. Make sure you contextualize your hypothesis statements. So going back to our example, we have completed step 1. We've checked all requirements and made sure that they are met. So now it's time to write the null and alternative hypotheses associated with this example. So let's go ahead and do that. So let me read this question to you again, in case you forgot what we were doing. So it says a survey was distributed at Anytown Community College. The students were asked if they smoked cigarettes and their gender was recorded. Is there sufficient evidence at the 5% significance level to suggest that smoking cigarettes and gender are related? So the null hypothesis is going to be that smoking cigarettes and gender are independent, and the alternative hypothesis is that smoking cigarettes and gender are dependent. So now we have checked all of our requirements. We've written our hypothesis statements. So now it's time to actually conduct our hypothesis tests. So remember, with hypothesis tests, you can use either a critical value or the p-value method. So in this video, I will demonstrate both methods. So in the past, we have used the normal distribution, or z-scores, and we have also used the student's t-distribution. Remember that both of these are symmetrical, you might notice, right? And for the normal distribution, we just have the one curve. With the student t-distribution, the shape of the curve changes relative to the degrees of freedom, which is the sample size n minus 1. Again, both of these curves or sets of curves are symmetric. So now we're going to use a chi-square distribution, and as you can see just from looking at this picture, we are no longer working with a symmetrical distribution. You can also see that there are still degrees of freedom that we're working with, and you can see, just like the t-distribution, you can see that the shape of the curve changes as the degrees of freedom changes. And you might notice that as we increase the degrees of freedom, this curve is becoming less skewed. Okay, so if you're wondering, well, how do you calculate the degrees of freedom for the chi-square distribution? The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. And again, the distribution becomes less skewed as the degrees of freedom increases. So in order to calculate the chi-square test statistic, this is our formula. So we have chi-squared is equal to the sum of observed minus expected values quantity squared divided by the expected values. So let's go ahead and calculate our chi-squared value one time by hand. So here is our formula. So here is the math. So let's just walk through this. So we have to do this 4 times, one for each of the 4 boxes in our data. So first we look at the females who said they don't smoke. So the observed number of females who don't smoke is 327. The expected value, those are in parentheses, is 306. So we have 327 minus 306. So we do that subtraction, we square it, and then we divide it by 306. Okay? And then we keep doing the same exact thing for the other 3 boxes. So for females who said they do smoke, there were 95 of those, minus 116, which is our expected value. Again, we subtract, we square, we divide by 116. And we continue on, and when we do all of that, we get about 28. So just a reminder, we are on step 3 of hypothesis testing, where we're trying to actually conduct the hypothesis test. And again, there are 2 ways to do that. We can use the critical value method or the p-value method. In practice, you would never do both methods for the same problem, but in this video, since this is an instructional video, I will be showing both methods. So let's go ahead and start with the critical value method. So we've already found our test statistic for chi-squared. Now we have to find the critical value for chi-squared so we can compare the 2. So the chi-squared test is, by definition, a right-tailed test. So we always use greater than or equal to in the inequality. Remember, the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. Our contingency table has 2 rows and 2 columns, so the degrees of freedom is 2 minus 1 times 2 minus 1, or 1 times 1, which is 1. So we only have 1 degree of freedom. So over here, you can see that we have generated the chi-square distribution for 1 degree of freedom. And we have chosen a right-tailed test, and we have put in 0.05, which is the area to the right of that critical value. And so the critical value we found is 3.84. So you will need to use some sort of technology to generate that. And if you want to learn how to use StatCrunch or RGuru or some other technology, you will need to use another video. That's beyond the scope of the purpose of this video. So in this video, we're just going through the process. So now we have both our test statistic and our critical value for our chi-squared. So now we can compare the two. So remember, if the test statistic exceeds the critical value, in other words, if it lands in this critical region, then we're going to reject the null. Otherwise, if it lands outside the critical region, or if it's less than the critical value of 3.84, we will retain the null. As you can see, the test statistic, 28, which we calculated a few slides ago, is much greater than the critical value of 3.84. This leads us to reject the null. Step 3, p-value method. Again, you wouldn't normally use both the critical value method and the p-value method in a single problem, but we're going to since this is an instructional video. So, to use the p-value method, we must use technology or a chi-square table to find the p-value. Doing that, we find that the p-value is less than 0.0001. In other words, it's very, very, very small. If the p-value is less than alpha, this means that the test statistic is landing inside the critical region, and that leads us to reject the null. If, however, the p-value is greater than alpha, that leads us to retain the null. As you can see from this table, the p-value is much smaller than alpha. Therefore, we must reject the null. Step 4, making a decision. Whether we use the p-value method or the critical value method, we must reject the null. Step 5, writing a statement. If we choose to reject the null, we need to write something along the lines of, there is sufficient evidence to support the alternative hypothesis at the alpha significance level. If we choose to retain the null, we will write, there is insufficient evidence to support the alternative hypothesis at the alpha significance level. However, both of these must be contextualized in the problem. So let's do that. So in this problem, remember, we're asking, are smoking and gender dependent or independent? And our alternative hypothesis, which we are supporting, is that they are dependent. So we would say there is sufficient evidence to suggest that smoking and gender are dependent at the 5% significance level. So now that you've watched this video, you should be able to determine whether all requirements of a chi-square test of independence have been met, calculate expected frequencies by hand, calculate the chi-square test statistic by hand, conduct a chi-square test of independence, and describe the chi-square distribution and explain how it differs from other distributions.